Western University. Today we'll be looking at this course, our Operation and Production Management. This semester, part 2 of this course. You remember semester 1 we did chapter 1 to chapter 6 in semester 1. This semester we'll be looking at chapter 7 to chapter 18. Okay, we're going to go all the way 7 to 18 this semester. Okay, so without wasting time, let's quickly take a look at what we have. Let's take a look at the outline. Here we're going to look at the global company profile. We're going to look at Harley Davidson's company and how they used to manufacture motorcycle. And then we're going to look at the 4 process strategy. Remember this chapter 7 is called process strategy. So in looking at this process strategy, we're going to identify the 4 ways by which strategies for processes are harnessed for production maximization optimization. And let's take a look at the next thing. We look at the selection of equipment and all of the important stages that ensure efficiency of process production and design. Now let's take a look at, we look at the production technology towards the end of the course, technology in services and process redesign. And then the first one is the Harley Davidson's concept. And here it was the only major US motorcycle company that were manufacturing motorcycle at that time. Now what did they do was that they emphasized on quality and lean manufacturing. So they were more of manufacturing quality than mass production. They were using what they call the lean manufacturing process for the manufacture of motorcycle at that time. Now, what are the things they needed? They needed materials. Materials are needed, right? They needed material, and they call it the material as needed, which is man system, or what they used to use. We remember at that time it was no automation, so it was man-controlled system. Now, what are the other things that they needed? They needed many variations as possible as they can in order to optimize and maximize the production of these motorcycles, right? Now, another thing was the schedule. They use what they call the scheduled repetitive production process. Okay, so here is the look at the flow chart of their system they had at that time. The first part was the frame tubing of the motorcycle. How to frame the tube, this tube, the tube of the motorcycle, how to do the framing, and then the frame building and work cells. They build the next stage was to build the frame and the work cells of every integrated cells on the frame of the body of the motorcycle. And then the frame machining, how to machine it and join the joints together, weld where it needs to be welded, join the whole entire frames together, and then hot painting frame painting. So they use hot paint in the frame painting when they were painting the frame. And then after that, they started doing what they call the assembly line, trying to assemble the shaft, the disc, the rocker, the bearings, and every other things in the process. There's so many things they did here: the oil tank, the shocks, the forks, the head bars, the feather works, the wheel work, the fuel tank, the fluid, the air cleaners, and then after that, everything was ready. The tube, the tires, and everything was ready. They went into test. They did 28 tests. Then they went to roller testing. After the testing, the first 28 tests, they did roller testing, and before they do grading. So this was the process of how they were producing their motorcycle using lean manufacturing process. And in this case, they were focusing on the quality, not quantity. They were focusing on quality. Now, today's course, let's take a look at the objectives, the learning objective, what we're going to achieve at the end of the day. First, we look at the 4 process stages or 4 process strategies. Then the second one is we should be able to describe all the 4 process strategies. The second one is to be able to compute and calculate the crossover points for different process. Then the third one is to learn how to use the tools of the process analysis to analyze the processes that we are using at different stages. The fourth one is to describe customer interaction in service process, to describe the customer interaction in the service process. And the fifth one is to identify research advances in production technology. Now the first one is the process strategy. What is a process strategy? Now here we say every organization, any organization, the approach they use in transforming resources into goods and services is called their process strategy. Every method you use, every methodology you adopt to transform your raw material, to transform your resources, your raw materials, whatever you have, into your finished product is called your process strategy. Now, the objective is to what? To create a process to produce offerings that meets the customer's requirement within cost. Remember that within cost, you must put into consideration the cost effectiveness. So you are going to satisfy the customer within cost range. Even if you're going to make any product to satisfy the customer without considering the cost, if it's outrageous, then you are out of place because the customer will look for alternative, right? So you have to look at this within cost and other managerial constraints. There are other managerial constraints that you have to put into consideration as well when you consider the process strategy. So a process strategy is really or simply putting together all the raw materials that are at your disposal as a firm or as an industry to make your finished goods and services that meets customers' satisfaction with the cost consideration and other constraint considerations in order to enhance profit maximization. Now let's take a look at the process strategy itself. How to produce a product. How do we produce a product must be carefully examined, right? To provide a service that will meet what? That will either meet, you either meet or you exceed customers' requirement. So you cannot go below the customer's requirement. Either you meet the customer's requirement or you exceed the customer's requirement. So you have to think of how, in your process strategy, in manufacturing processes, in your process strategy, you have to think of how you can make a product that either meet the customer's requirement or even exceed the customer's requirement. Not only product, including providing a service, okay, like telecommunication service, education service, hospital service, including service, not only product. So either you make a product, you make a service, well, whichever way, but you have to meet the customer's requirement or if we exceed the customer requirement. That's number one. Or to produce a product. Another one is to produce a product or a service that meets the cost and managerial goals. Okay, you must meet the cost requirement and the managerial constraints and constrictions. Is that okay? Now let's quickly take a look at another stage of the process strategies. Now, another thing we look for when you harness you're planning your process strategy that gives the ultimate goal or objectives of the factory or the industry is you have to look at how the long-term effect, what effect do the long-term planning or the long-term process or the long-term operation of the factory, how does it affect efficiency and production flexibility, and how does it affect the cost and the quality of the product at the end of the day? Okay, how does it affect the cost and quality of the product? Now let's quickly take a look at furthermore on the process strategy. There are four basic strategies that are being used by different organizations, be it a production organization or production factory or service industry, whatever it is. There are four strategies that are being employed or put in place. One is the process focus, focusing on the process itself. Two is the repetitive focus. Three is the product focus, and four is the mass customization, mass production, mass customization. Okay, so within these basic strategies, there are many ways for implementation. There are many ways you can implement these four things that we just talked about. Here is a process volume variety flow diagram. Okay, here is looking at considering maybe things like high varieties, low volume, and so on and so on. You're looking at volume against varieties in this diagram. Okay, volume against the variety. Sometimes you have low volume and high variety. So for example, let's take a look at them one by one. Poor strategy. If you have poor strategy, you have what we call both fixed and variable costs are high. So when you in your factory, when you at the end of the day, when your fixed costs and your variable costs are high, you know your fixed costs, right? Like your cost of building, cost of your machineries and all of this. These are your fixed costs, right? These are your fixed costs. Your variable costs may be cost of raw material, cost of inputs, and here and there and here and there. These are your variable costs. When both your fixed costs and variable costs are super high, what it means in the process and in process strategy. In process strategy, in operation and production management, it simply means that your strategy is poor. Your strategy is poor. Now, when you have, meaning you have low, you will have end up having low volume. You fall in the category of low volume. You fall in the category of low volume and low varieties. You'll be like low volume and low variety because your strategy is poor. Now, in the case of repetitive, you're either like moderate volume and moderate variety. Like in the case of automobile motorcycle by Harley Davidson. Okay, home appliances manufacturing. These ones usually fall in the repetitive process, which usually fall between the low volume and medium volume. You can say that, and medium variety. Now, in the case of product focus, like commercial baked goods, like steel, like glass, like beer. This one like Frito Lay. Okay, this one you focus on the volume. Okay, the volume is high, but the variety is low. Variety may be low because you're just manufacturing one thing and you try to perfect it and make more of it. So you make more volume because here you might mass produce and then the varieties. But in the case of mass customization, like in the production of their computers, like Apple computers, their computers, and so on and so forth. Here, you have high volume and high varieties. You have high volume and high varieties. It's difficult to achieve a huge reward when you are able to do this when you use mass customization. Process focus, you have low volume in the process focus and low variety, low volume and low varieties, or low volume high varieties. It depends on the project you're working on. Like in the case of hospitals, you have low volume but high varieties. Okay, now let's move on quickly. Process focus, the facility, they are organized around the specific objectives or processes that you want to use them for. Okay, and then the purpose of the equipment, you need the purpose, equipment, and skilled personnel in the process focus. So you need very skilled personnel when you're doing what? When you're planning your process focus, okay? To deliver the desirable objectives of the establishment of the factory. Now, a high degree of product flexibility should be considered. Product flexibility when you are planning your process focus, okay? Now, typically high variable cost and low equipment utilization is desirable here. Okay, your variable cost may vary, but you must find a way to use low equipment utilizations when it comes to this planning. Now, product flow may vary considerably, making planning and scheduling a challenge. Okay, now let's take a look at an example of process focus. Like in the case of the hospitals, treatment in the hospitals, and all of this, you can see that we have so many surgeries, sick patient, baby delivery, emergencies in one hospital. So many of these, so they are handled by different departments. They go in as inputs into the hospital, but at the end of the day, we have low outputs. Maybe some people will die, some people will not make it out of the hospitals. We have low output at the end of the day, and this falls under process focus. So the hospital should be able to focus in each of the departments and bring technical experts to handle each of the various activities as it were in every department. Now let's take a look at the repetitive focus. Now we've left the first one, we're in the second one, which is the first one was process focus. Now the second one is the repetitive focus. Now here, under repetitive focus, facilities often organized as assembly lines. So it's not like just you're making a single product or a single service. Here, you make an assembly line to make organized product, okay, in a repetitive focus, because it's a continuous and repetition, and you're trying to make things according to size and according to the design, according to size, according to design, according to proportion, according to calculation, according to measurement. So it's a repetitive focus, okay, so that you have many things produced that look exactly the same because they're done by the same process, and it was really focused. This is characterized by modules with parts and assembly made previously. Okay, this is characterized by the modules that have been made before. Maybe these modules were made by the process focus. Now you bring this, you plug them together. You plug these different modules together to work together as an integrated unit in order to as an integrated unit or as an assembly line in order to produce a better output or more output that are similar. Now modules may be combined for many output options. So like I said already. So here modules are combined, different modules that have been made in the process focus put together to give a competitive focus. Here is less, we focus less on flexibility, okay? Here is less flexible than the process focus facility, but here is more efficient, okay? The repetitive focus is more efficient, but less flexible, less okay. Now let's quickly go on still on the diagram example of in the manufacturing of a motorcycle. In the manufacturing of a motorcycle, we have so many input, multiple engines and wheel models have been plugged in, and few models will be out, and at the end will be operated here. And at the end of the day, we have models combined working together for a better output. You can see the outputs. Many modules are combined from the input to give a modular shape, a modular. So many modules. Some modules were making the wheel. Some modules were integrating the tires and the tubes. Some were making the handle, the shaft. So these many modules are put together at the end of the day to produce one modular product. Okay, one integrated modular product that's desirable. Okay, so this is for repetitive focus. Now let's take a look at product focus. You know, we talk about process focus, repetitive focus. Now we are going to product itself. We are going to product focus. We are going to product focus. Now, in these, facilities are organized by product. Okay. Facilities are organized by product because we are talking about the product focus. So all facilities are organized by the product. You are considering the product, and product is your focus. And then here we have high volume but low varieties of product. High volume in but low varieties. Meaning what this means is that you produce very many products but that are similar, that are same, like they are perfected together. Okay, let's say for example you're making the printing machine. Okay, a specific printing machine. You're going to make like laser printers. You're going to make so many volume of it that are same, not different. Is that okay? So here includes a long continuous production run that runs and enable efficient processes to take place. Now here also we have what we call high fixed cost but low variable cost. High fixed cost like heavy industry machineries, okay, like the heavy machinery that are fixed that are helping you to make the product. Heavy machinery brings what we call the high fixed cost, but the variable costs are very low because you are not you just bring the raw material, but the machineries that is producing the product for you, the machinery has high fixed cost. The variable cost is very low. And then here also we have less skilled labors because machine is doing everything for you. You don't need that one. Then still on the product focus, an example is like when you're making your Frito-Lay. Okay, when you're making your Frito-Lay, there's this popular one during the Champions League that advertises during the Champions League, the Lays. Okay, and the what do you call it? This one they make with the corn, potato, water, and seasoning. Okay, chips, chips. Okay, when you're producing chips, it's about product focus. You have to focus on the product. Here you have high volume and no variety because there's no difference or differences in the variations of the product. The product you're making chips, okay, you're making chips, and you're making high volume chips. So here you're focusing on the product. You're focusing on the product. You put a lot of inputs like the corn, the potato into the machine. The machine that you build, the factory machining, is what brings about high fixed cost. But the variable cost is very low, like the corn, cost of the corn, potato, water, These are not so super high cost. Okay, the variable cost is low. And then you have high volume product, but low variation in the. Then the fourth one is the mass customization. Mass customization strategy. Here, we normally have what we call the low cost productions of goods and services in order to satisfy the increasing yearlies of the customers. People want to buy things a lot, but they want it cheap. So you must produce in order to reduce your cost. If you divide the cost by the number of units, you see you would have had a reduced cost. So mass production helps to reduce the cost in order to satisfy almost the 8 billion people in the world, so that are yearly for that particular product. Okay, so here mass customization helps to reduce cost and also satisfy customer yearly. Here this process combines flexibility of the process focus with the efficiency of the product focus. The product focus has something to do with efficiency, and the process focus has something to do with flexibility. So the mass customization combines the advantages of the advantage of the process focus, which is flexibility, and the advantage from the product focus, which is efficiency. Okay, so efficiency from product focus and flexibility from process focus are being combined in this case. Is that okay? So that's that. Now let's move on. A good example of this is Apple computers, your MacBook, your Mac computer, your Dell computers. These are mass produced. They are mass produced. So both efficiency and flexibilities were combined in the actualization of this product, in the achieving this product. Here, many things are combined. You bring your chips by Intel. Intel will manufacture the chips, then the hard drives, the software, and cases for covering the computer, the cases. All will be assembled in the modules, in the modular factory, and there to bring out the product, the PCs and the notebook and the laptops and everything that is being produced by this factory. Now, making mass customization work, how do you make it work? You have to have an imaginative product design. You have to imagine what product, the shape, the design, the efficiency, the utility, and everything. All this you have to factor in. You have to imagine the new product design before you make it. You have to sketch it. You have to process it. You have to understand it. You have to imagine how it works. And you also have to look at the flexible process design, how flexible the design process will go. You have to look at all of this. And then you have to tightly control inventory management in order to reduce waste and optimize the process. And then you have to look at the digitized communication track orders and materials that follows the process. And then also you have to be very responsive partners in supply chain. All your partners in the supply chain must be ready to supply ASAP when you need these materials. And they have to be very responsive, okay, in order for these mass productions to take place. Okay, here is a comparison of the processes. And we have 4 pages comparing both the process focus, the repetitive focus, the product focus, and mass production. Okay, we've talked about all of them, but here they just summarize in a table. Okay, now let's quickly go on to crossover chart example. Now, here we say evaluate 3 different accounting software products. Okay, we want to evaluate 3 different accounting software products. You say calculate the crossover point between software A and software B, and between software B and software C. Now you can see the software total fees cost is 200,000, and the dollar required per accounting report is $60 per one accounting report. Okay, for software A. Software B is $300,000, and the dollar required per report is just $25. For software C, it's $400,000, and the dollar required is just $10. Now let's calculate the crossover. Okay, so to do the first one, then we're going to say this 200,000, which is our fees cost. So fees cost plus variable cost, right, equals to our total cost, right? Fees cost plus variable cost for software A should be equal to, we create an equation, should be equal to the fees cost and variable cost plus variable cost of software B, right? Of software B. So here we can be writing A, like software A, and here software B, software B. So we want to calculate the crossover points, right? The crossover points where margin of safety and margin of profit and all of these things start to happen. Now let's quickly take a look at that. Now the fixed cost is for the software A is 200,000. So we write down the 200,000. Okay. Since I already have it here, so we write down the 200,000 plus the variable cost 60 times V1. Okay, 60 times V1 from here. This 60 times the V1. 60 is the for one product. The V1 is for the many variables. For the many variables. So we call it V1. 60 times V1. And then we come here. We say is equal to this for the left side of the equation. Is equal to the 300,000 for software B, which is the total fixed cost, plus 25 per 1 unit cost and V1 for the fixed cost. So we multiply this by this, we get 60 V1. So on the left, we have 60 V1 plus 200,000. So we collect like terms, like we do in normal arithmetic. We bring this 25 V1 to the left. It becomes 60 V1 minus 25. So here we have 60 V1 minus 25 V1. 60 V1 minus 25 V1. So this will be equal to 35 V1. That's how we got this 35 V1. So if you do this, I put it in a bracket so that you understand how we got this 35 V1. So that led us to this 35 V1. And then you bring this 200,000 to the right. It will now be minus when it goes to the right. Because 300,000, this is normal mathematics, arithmetic. Becomes 300,000 minus this 200,000. When the 200,000 comes here, it becomes 100,000. 300,000 minus 200,000 becomes 100,000. So you divide both sides by 35, you get 2,857. So for V1. So it means software A, this one, software A, this software A, right? Why this is software B? Software A is almost economical from 0 to 2,857 reports that you're going to make. So beyond this, it will be software B. So software A is still economical even though you are paying 60 per report, but up to 2,857. Beyond 2,857, software B will overtake the economic importance. Now let's do between software B and C. Now software B is 300,000 plus for the total fixed cost plus 25 times V2 equals to 400,000 for the total fixed cost for software C plus 10 which is the per unit charge for one report for software C times the fixed cost. So if you collect like terms, this will be 25 minus 10, that's 15 V2. And then you bring this one here, it'll be 400 minus 300, you get 100 as well. So V2 will be 100 divided by 15, you get 6,666 approximately. So if you have this, it means software B is most economical from 2,567 to 6,666 report. Now, the big question is, where is software C now more economical, even though you are paying $10 per report? Software C will be economical after 6,666 report. Now, when you now start 6,667 report, software C will now be more economical. Is that okay? So these are the crossover calculation you need to know. These are displayed in the chart. Okay. Remember, this is a fixed cost. You did this in economics, basic economics. This is the fixed cost, the straight line. Like in physics, you say this is a constant. In speed time graph, this is a constant speed, right? So we call it a fixed cost. Why this is a variable cost? Okay, this is a variable cost for software A. So software A has low volume, high variety, and it's process A. Now this one, you can see, the steeper it is, the higher the variety and lower the volume. So take a look at this repetitive process. You can see that this one is just moderate between this and this, just like in the halfway. medium, medium volume, and medium variety. That's the repetitive process. Now for C, process C, it has a high volume and high variety. High volume and high variety. Okay, so put together, all three of them put together, we have the 200,000. Look at the fixed cost for software A, and look at the variable cost for software A. And this software A fall under the process A. Software A fall under process A, where we were focusing on the process strategy. When the company is focusing on the process strategy. Now software B fell all under uh, under repetitive process. The repetitive process. Okay, like the case of the hospital and so on and so forth. Then software C fell all the total process. Okay, this one fell under process C, where you have high volume and low variety, like when you're making the chips, the one I mentioned, the chips. You mass produce, but the variety is very low. There's no much variety, but the product is a lot. The product is a lot. Okay, so that's that for that. Now let's move on. Now the focus processes. Let's look at the focus process. Focus brings about efficiency. When you focus on each of the process, you eventually optimize the efficiency and efficacy of the production process. And then another focus helps to create in depth on the product line rather than the breadth. You create a depth, in depth on the product rather than depth. Then focus can also be on the customer. You can focus on customers in order to satisfy them. Focus can be on your product. You can focus on your product to have quality product. You can focus on your service to give quality service to customers. You can focus on technology to improve your production system and production technology. So focus can be on any of this. Now let's take a look at selections of equipment. Decisions can be complex as alternate method may be available. When decision become complex, you may find alternate measure, right? Now, let's look at important factors maybe that you need to look at when you're making decisions in your production. One is cost. You have to look at your cost. You have to discuss about cost. Don't make it too much. And if it's too much, people will not be able to afford your product. You go to alternative products. Then another thing you look at is quality. Do not compromise quality even though you want to reduce your cost. Another thing is the cash flow. This product you're going to make, how does it bring a cash flow, regular cash flow to the organization, to the factory? Then another thing is capacity. What capacity do you have to mass produce quality, to produce what, to reduce cost? What capacity do you have? What skilled staff do you have? What do you have? Everything. Then another one is the market stability. Do you have a high income priority market? You have people that have high purchasing power priority. You have a stable market, or do you have a dingly market, or do you have a plan for exporting your product? Do you have a market for your product, and how stable is the market in order to not to affect your production? Then another one is flexibility that you need to look at. Now, when you talk about looking at flexibility, you have to see to the context of how you can swing from improving and bringing things that easily give a better service to the customers. Now, flexibility is the ability to respond with little penalty in time, cost, and customer value. Ability for you to respond quickly with growing demand. People, instead of creating queue, like if you go to McDonald's today, you see that they have machines that you can order yourself. You don't have to be in the queue and waiting for the people to serve you. So you can order. If you go to a movie theater, like you want to watch movie, you can book the movie yourself. You can even buy it online. So all of these are flexibility. You have to introduce more machinists that helps to make the process faster, automated, and quicker. So these are flexibility. The business must have these kind of flexible characterizations that enable optimization and maximization of service delivery. So without all of this, then you begin to have issues and complaints here and there. So flexibility is very enhanced and very necessary in order to give a quantitative or competitive advantage. If you want to have a competitive advantage in your operating environment, in your natural competitive system, because you're not alone. It's not a a mono system, because what you make it, other people are also doing the same thing, rendering the same service to customers. So in order for you to stand out, you have to find a way to be flexible and introduce things that are customer friendly and enhance customer usage, and reduce difficulty and task in accessing and delivery and payment, even payment system, the gateway payment system that you operate into your system. All these things must be flexible enough to enhance customer satisfaction. Then another thing is that maybe difficult and expensive. Okay, maybe difficult and expensive to be flexible. Flexibility is not cheap, because you bring in some a little bit here and there technology and machines that have more defined today's laws of physics. You bring in some of those things into incorporate into your business, so they're not cheap. So it's going to come at a cost. But these are some necessary sacrifices in order to have a competitive advantage over your opponents or over your competitors. Okay, now let's without flexibility, change may mean starting all over. It may not be easy for you. Now let's move on quickly. Process analysis and design. Let's take a look at the analysis stages and design. When you are analyzing and designing process, there are some questions you need to ask, or you need to answer these questions. One is the process designed to achieve a competitive advantage? If your process is not designed or is not looking at addressing or giving you a competitive advantage over other competitors, then it's not a good plan. It's not a good design. Does the process eliminate steps that do not add value to the product or to the system? If your process do not create or eliminate all those hurdles, whatever you want to call it, all those bureaucratic, crazy steps and processes. So the process must eliminate the hurdles. Every hurdles that will slow you down, that will slow the customers down, that will bring impediment, that will impair you from reaching the great, satisfy your customer maximally, then this is not a good design. And then another thing you should ask yourself, or you should jot down and find out whether your process analysis and design satisfy these questions. Another question is, does the process maximize customers' value? Is it going to maximize the customer's value? If no, then it's not a good process. And then another thing is, will the process win others? Will it win others, or will it begin to make you lose? Now, after that, let's take a look at tools for process analysis and design. What tools do you need? You need a flow chart. You need to scheme things, see the flow of things, the movement, the production, and all of these things from raw material, from your suppliers, your supply chains and all of this concept. You have to factor them in and do alterations and iterations of numbers and numerical calculations to know where the raw materials from, where they're coming from, the product differentiation, all of these things you go to factor into. So you have to have a flow chart that addresses all these things. Then you have to have what we call the time functioning mapping. To see the time functioning mapping, we add time on the horizontal axis to the flow chart that you have designed. Then the process chart also. In the process chart, you will be able to use symbols to analyze the movement of people and movement of materials, whether from the supply chain to the factory, or moving the finished product to the customers. All of this have to be put and well planned out, in the process chart. Okay. Then another one is the value stream mapping. And the value stream mapping has to extend time function mapping to see where value is added in the entire supply chain. If not, then you have to redesign. There's service blueprinting. This one we focus on the customer. When we talk about service blueprinting, it has to focus on the customer and provide interactions with the customers, meaning a feedback system, so that people can tell you where your product is not doing well, and you quickly correct such, and also identify the potential failure point in your everything. So these are the flow charts, as it were, in the process chart. Now let's quickly move on. The value stream mapping steps that you need to take. When you begin with symbols for customers, for suppliers, and for productions to ensure the big picture. Okay. Then another thing is to enter customer order requirements, the order, the requirement based on order. And then another one is to calculate the daily production requirements. Another one is to enter the outbound shipping requirement and the delivery frequency of your product. All these have to be marked. And then another one is to determine the inbound shipping method and delivery frequency. All of these have to be totally and optimally mapped. Then still on the value stream mapping steps, you have to add the process steps also, like your machine, your assembly, your sequence, whether from left to right, right to left, whatever flow algorithm you have to. Then another one is to add communication methods. Okay, add their frequencies and shows the directions with arrows for the communication techniques. And then another one is to add your inventory quantities between every steps of the entire flow algorithm. You have to. And then another one is to determine total working time. The total working time, that's the value added time. And the delays, which are the non-value added time. You have to differentiate and integrate them and factor out what you can simplify. So you can see the diagram from the supply to the machine operators, and then to the next component, mounting, assembly, testing, package, and then after that, the package is made and shipped to customers. You can see this is the manufacturing management, the management of the organization, and this is the production supervisors. These supervisors are supervising you. There's a supervisor for machine operations, there's a supervisor for mounting, component mounting, a supervisor for assembly, there's a supervisor for testing, a supervisor for packaging. All of this, after this is done, then they are shipped or delivered to customers. So the management is here making the decision, ensuring customers are happy, ensuring suppliers are happy, and ensuring the factory is doing what it needs to do. And then here you have what we call the value stream mapping diagram. And here is the service blueprint, which is like a flow chart that tells you whether your customers are getting the desired satisfaction and happiness, as it were. Now let's go to special consideration for service process strategies. Some interactions with customers is necessary, but this often performance adversely, right? Now we say the better these interactions are accommodated in the process design, the more efficient and effective the process may be. But sometimes when you when you dwell too much into incorporating the customer's interactions into your design, this may also bring a lot of issues. So in as much as you trying to be moderate in all of this, find the right combinations of cost and customers interaction. Yes, that's the point I'm trying to make. You have to find the right, because you cannot pour everything the customer say. Customers, they never 100% satisfied. They can tell you, put this, add this to it, make this like this, make this like this. So if you go to consider everything they've said, your cost will be so high that at the end of the day, you will be out of business. So you must find a dichotomy, like a trade-off between the cost and the customer's interactions in the whole chain of system. Here is what we call the service process matrix. You can see the mass service, you can see the service factory, the service shop, and the professional shop, and so on and so forth. This degree of labor against the degree of labor plotted. Okay. Now let's take a look at mass service and professional service. Here, labor involvement is very high, focused on human resources high, selections and trainings are highly important. Yes, you must train your staff and retrain and keep them ahead of the game. Keep them to be on top of their game, or else you will make a product that will not see the light of the day in the market. Service factories and service shop. Here, automations of standardized services are needed, restricted offerings are provided, low labor intensities respond well to process technology and scheduling, and so on and so forth. So here is a table that is showing all of them. We're looking at improving service productivity. Here we're looking at separation strategy, service, self-service strategy, postponement focus, and so on and so forth. Okay? Here are the different techniques, and here are the examples. Okay? Now let's quickly move on. Production technology. Let's go to production technology. Now, the future of operation and production management is increasingly tied to the collection of data from critical points, right? Critical points that are necessary for optimization. Now, technology shrinking the cost of digital sensors, right? Technology is reducing the cost of your production. Now we are using digital sensors. we're using coding to create the language or whatever we want, and we are computing, right? Which are being embedded in our machinery processes, making our machine to be robotic. Machines are now robotic. So sometimes we are eliminating the super cost. It's just that the fixed cost is high at the beginning, but in the long run, you're going to have a super factory. But here we are eliminating the super labor cost that we used to use, where we have so many people working and we pay a lot. So in the long run, we have defeated cost because now we are making our machine for production super robotic. Now, huge streams of data are captured and transmitted, cleaned, and interpreted by the production technology of nowadays. Now, digitization is superseding traditional human data collection, human data production, human data. So all of these are being replaced by machine productions, right? By robot. You can simply say by robots. So here are the production technology. We have machine technology, automated identification system. We have the process control technology. We have the visual system technology. We have robots. We have automated storage and retrieval system. All of them are robotic nowadays, okay? We have automated guided vehicles and all of this. So if you look at this, what is in all of this is to increase precision, productivity, flexibility, reduce environmental impact. All these are the advantages and disadvantages. We'll talk about the advantage. Computer numerical control, adaptive manufacturing processes to produce products by adding materials, not removing them. All of these are the advantages that comes with this automated system. Now, whether it's AIS, which is the automatic identification system, or the RFID, radio frequency identifier, in any of these, it's becoming automated, right? Here we get improved data acquisition, reduced data entry errors. Errors have been minimized with this system that we developed, increased speed, increased scopes of process automations, and so on and so forth. The process control sensors used to collect data, or like in those days when we use human, the process control use what we call the real-time monitoring and the control process. Sensors help us to collect the data. The devices read data on periodic time or periodic interval, and then measurement transmitted to digital signal, then sent to a computer to analyze, to process, to design, to whatever. So everything is automated. Computer programs are analyzed by the data, analyze the data, and so on and so forth. And there is less error, there's improved system control, efficiency, and all of these have become advantage because we are using automated system and robots. Okay, both the visual system, any system you mention nowadays that involves production technology, all have all these same advantage. The lower cost in the long run, they never make us feel bored. There is no I'm sick, I cannot come to work today, and then you're losing cost, you're losing money, you're losing whatever. Machines are always there 24 hours, even in public holiday, every day, any day. Even you want 24 hours, machine work for you 24 hours. So all these are advantages that have outshined the normal traditional human production system. Now we have the robots. Okay, the robots, like all of them are robotic nowadays, okay? The robot perform monotonous and dangerous tasks that even humans cannot produce, or dangerous for humans to do. They perform tasks requiring significant strength and endurance that have become challenged by humans' strength nowadays. Now, generally enhance consistency and accuracy. The another one we have today that are robotic in design is the automated storage and retrieval system. Here, machine helps us to store our things and retrieve them for when we need them as an organization. Another one is automated guided vehicle. Now we have vehicle, you don't need a driver. Electronic system will control your cart in shopping center. We control your cars on the road. So you can see we're improving, we're going somewhere. And then this will help in the factory. You will have vehicles that will be taking every part to the main machine for assembly and for production. And this will be used for movement of products and individual, as it were. Then we have the flexible manufacturing system. All of them are computer systems, so they have all the same similar advantages and disadvantages. We have computer integrated manufacturing system, which extend flexible manufacturing. We have the backward to engineering and inventory control. We are forward into warehousing and shipping and all of this. These are used in the computer aided manufacturing, helps to arrive at this. Then we have the computer integrated manufacturing, which helps us to manufacture where we use computer to control the robot for both storage, for both manufacturing of our product, for both assembly line, for both whatever stages that this will have. Now let's take a look at technology in service. First, let's look at the financial system. We use it to debit card, we use it to create debit card, MasterCard, Visa card, all of these things. Electronic fund transfer like the ATMs. We use it for internet stock trading. We use it for online banking via the telephone. We have now what we call the Apple Pay, Soso Pay, and that Pay. Therefore, education. Number 2 is education. That's what we are using for Wisdom University today, right? The technology service is what we use. They are used for online journals, test online book, what you call the e-books, interactive assignment via Zoom, Zoom meeting, Zoom classroom, Zoom whatever, Blackboard, like the mirror board we use for lecturing and so on and so forth, the smartphone. So for education, it has found a very superb, a very wide. Today's conferences and presentations are done online. You want to attend conference, about 70% of conferences are done online now. The remaining 30% or 20% are the people who will come to the physical venue. But about 70 to 80% of the people who are present in a conference do it online. Vivas are done, PhD and master vivas are done online using this technology in service. Now, utilities and government use this one. One of the utility services are automated one-person garbage truck, optical, mail, scanner, flood warning system. If there's going to be flood, there's now warning meters that allows homeowners to control energy usage. Also, you have meters that tells you how you're using your energy. All this is technology. And then another way where the government also for tax and everything, all of these things. The restaurants and food, you now have wireless order. You can order your food from your table and so on and so forth. Wireless order from server to kitchen, robot butchery. Robot are now butchery animals for all of these things. Transponders monitor the traffic. So all of these are advantage. In communications, they are using interactive TVs, e-books, speech recognition. For hotels, they use electronic check-in, check-out, system, mobile web booking, and so on and so forth. Then in wholesale and retail, point of sales, technology, I use e-commerce. You buy, you shop online, and so on and so forth. Amazon, eBay, wherever you're buying from, Alibaba.com, Lazada, and all of this world-class shopping center. So we talk about transportation. They are used for automated toll booths, satellite-directed navigations. They are used for navigation. You see, when you talk of Waze for navigation, Google Map for navigations. All of these are technology in service for transportation. You talk about healthcare. They now have online patient monitoring system. We have online medical information system. We have robotic surgery now. Robot performs surgery. We have artificial intelligence for medical diagnosis. And then for airlines, we have ticketless travel. You don't have to buy ticket. No, not that you don't have to buy ticket. You don't have to have a physical receipt ticket. Okay? You don't have to have a physical receipt ticket. You have scheduling. Okay, you have internet purchases. You have body passes downloaded as code on a smartphone. You don't have to get a physical body pass. You just download it as a code on your smartphone. And then you touch the RF machines when you get to the airport. And then you are in. Then process redesign. I think this will be our last page. So we say for process redesign, the fundamental rethinking of business processes to bring about dramatic improvement in performance is very important. So sometimes even existing process, we can reinvent it, we can re-engineer it and redesign it and re-improve it and re-evaluate it, and so that we can have even better output, as it were, better than what it was before. Okay, we can question assumptions on the previous processes and improve them based on critical thinking and research and so on and so forth. Now, design requires re-examinations of the basic process and its objective, whether it has served its objective for which those processes were created. Now, focuses on activities that cross functional lines are very essential, and any process that is a candidate for redesign is enhanced and is encouraged. Okay, so with this, we come to the end of our today's class. Thank you for joining us. Thank you.